Unit 11 exam review. We're going to be covering section number 2, area of a sector. Quick revisit, we talked about in the last video the idea of arc length and area of a sector. Arc length is a portion of the circumference, which is the formula is 2 pi r, and area of a sector is a portion of the area, which we know from a circle is pi r squared. So really what we're doing is we're setting up a ratio of the area of the sector to the full area of the circle, and arc length of the distance on the edge of the circle to the full distance around a circle, the circumference 2 pi r. To create a proportion, we create a ratio of degrees, and we set them equal to either the arc length over 2 pi r or the area of a sector over pi r squared. So we have this ratio of degrees to ratio of circumferences. For area of a sector, we have a ratio of degrees to ratio of areas. So from here then, let's go ahead and take a look at our area of a sector. We want to go ahead and find the shaded area. So let's take a look at that proportion, which is a ratio of area degrees to a ratio of areas. We're asked to find the area of the sector here. So that's going to be our unknown value that we solve for. We are given the degree here of 210. And we're also given the radius value, which we're going to square. So this is in fact going to be 3 squared. So we're given the radius value there. So from this proportion, we're going to go ahead and we're just going to cross multiply and solve from there. Where we're going to have to divide by 360, which gives us, if I multiply all the numbers and leave pi, 1,890 pi over 360, which goes to 5.25 pi yards squared, because we're finding an area here. Or if we wanted to go ahead and actually multiply this out, that gives us x is equal to 16.5 yards squared. Multiplied out. Right? Once again, coming from making a ratio of degrees to ratio of areas. In this case, we're finding the area of our sector over the full area pi r squared. For B and C, we are going to once again use the same proportion that we had, degree ratio equal to degree area ratio, because we're again trying to find here, we're trying to find the radius, and here we're trying to find the central angle, and we're given the area of our sector. So let's go ahead and set that up for B. Degree ratio equal to area ratio, and we're going to substitute all our known information. Here we're given the degree measure, 200 central degree. In this case, we're given the area of the sector, which is listed as 90 pi meters squared. We're actually trying to figure out what the radius is going to be. Radius x is my unknown, which is listed there as squared. From here, we're going to go ahead and simplify first. We can divide out our pi values. And from here, we'll go ahead and cross multiply. 225 degrees times x squared equals 360 times 90. We'll divide both sides by 225. That gives us a value of 144. To get the x by itself, we will take the square root of both sides, leaving us with x is equal to 12 meters for the radius value. For C then, we'll start off pretty much the same way. We are asked to find the central angle here, and we're given the area of a sector, so I'll set up my degree ratio to area ratio. And now our known information. We're trying to find the degree measure here, so that is my unknown value. We're trying to find the degree measure. We're once again given the area of the sector as 282 feet squared, and we are found the radius value of 14 squared. Now, this is just a proportion that we can go ahead and cross multiply to solve. I would like to make note, it feels weird that the pi is still in there, but we're not doing anything wrong here. Again, we're looking for an angle measure. It's going to be less than 360. So as long as our answer is less than 360 degrees, which is how many degrees are in a full circle, we should be okay. So let's go ahead and continue cross multiplying. X times 14 squared times pi is equal to 360 times 282. We'll divide by 14 squared times pi. That will approximately equal 164.8. I'm going to round it up to 165 degrees. Again, this answer makes sense because we're looking for a degree measure less than 360. This actually almost looks less than half, which we know is 180 degrees. So 165 definitely makes sense in this particular scenario. There is the proportion we use to find the degree measure. Once again, notice in each of these we set up at the ratio of degrees to ratio of areas, ratio of degrees to ratio of areas, pi r squared, ratio of degrees to ratio of areas, pi r squared. Let's take a look at problem letter D. Pizza has a diameter of 16 inches. What is the closest to the area of one slice? So that's our giveaway that we're doing a area of a sector problem. If the pizza is divided into 6 equal pieces, let me draw a diagram real quick. So here's a circle. What I'm doing is I'm dividing this into 6. And we cut this into 6 equal pieces. Well, I want to figure out the area of one of these slices. Well, I know that the diameter is 16 inches, so I know the diameter equals 16 inches, which means that my radius is equal to 8 inches. So one of these pieces, 8 inches. Well, in terms of figuring out my proportion, we can set that up. I need to set up a ratio of degrees to a ratio of areas. Now, I'm trying to find the area of this sector, so this is in fact our unknown value. We just found out that the radius, the diameter is 16, that means my radius is equal to 8. So we have 8 squared there. What is the degree measure going to be? Well, if we think about it, there are 360 degrees inside of a circle. 360 degrees inside of a circle. If I'm dividing that into 6 equal pieces, well, that means that each section is going to be a 60-degree section. 60, 60, 60, and so on. So that means my degrees that we're looking for is going to be 60 degrees. Well, from here, this is just a simple cross multiplication and solve. 360 times x, 8 squared times pi times 60. We're going to divide both sides by 360, giving me x is approximately equal to 33.5 inches squared. That would give me an answer choice of D. Notice again, this one is also going to be on the test. We didn't initially give you the degree measure right off the bat or the radius. We had to do a little bit of work beforehand as opposed to the diagrams where everything's given to you. So just be mindful of that. Other than that, we set up ratio of degrees to ratio of areas, and we were pretty smooth.